Hi everyone, welcome to my channel, Math is Fun channel. Again, this channel is an educational channel to help you understand your lessons in mathematics. This channel is intended to those who are doing the online classes out there, hello, and those who are answering their module. This will help you understand and build your concept in your math lesson. So please not forget to subscribe my channel and share this channel to your friends out there so that you can help them improve their performance in mathematics. That is so exciting, right? Yes, so I hope you'll be able not to forget to subscribe my channel and share this one to your friends out there. So now we will go over with our discussion for today's video discussion. It's all about the international system of units. Oh, yes, it's related to measurement. So now, to start with our topic, of course, we have to be guided with the main objective for this main objectives rather for this video discussion. So here are the objectives. First, we're going to use tools and equipment appropriate to scientific investigation. That's the first objective. The second objective that we have for today, we are going to use metric measurement devices in an investigation. So now, to start with our discussion, let's start and pause for a moment and try to reflect with this question. Why do we need to be able to measure things? What do you think? So try to think about it. Any ideas? So now, suppose we wanted to measure a 2 by 4 for building a house. Numbers by themselves don't make sense. Do you agree? If you disagree, then it's your opinion. Okay, so let's say a board is 350 long. Units by themselves don't make sense also. So a board is meters long. So to make sense, all measurement all measurements rather need both a number and a of course, a unit. So now to make sense, all measurements need both a number and a unit. So we need a number and a unit when we use to measure things, right? Yes, exactly. Now let's go over something related or a term related to measurement. We call it estimation. As you can see, estimation is using your knowledge of something similar in size or amount to determine the size of the new object. Let's say it helps to make a rough measurement of an object. And it is usefully when you are in a hurry and exact numbers are not required. In short, the importance or we use estimation when we are having or we have to make a rough measurement of an object. That's the first reason. The second one is we use estimation when you are in a hurry and exact numbers are not required. So now, something related to estimation, we will define now precision and accuracy, very important in measurement. So when we say precision, it is a description of how close measurements are to each other. So that is precision. When we say accuracy, as you can see on the screen, it is something or it is comparing your measurement to the actual or accepted value. So again, when we say precision, it is describing on how close the measurements are to each other, while accuracy measures or it compares the measurement to the actual or from the actual or accepted value. So these are the descriptions between the two terms, precision and accuracy, which play rather a great role in measurements. So now, why use the SI system? So in the US, we use the English or standard system. Most of the rest of the world uses the metric or the SI system. Just like Philippines, we use the metric system or SI system. So when we say SI, that means International System of Units. Les System International de Units in French. Remember, last video discussion, it was the French people who introduced, who established the standard way of measurements. So now, the SI, or the International System of Units system, is the form of measurement typically used by scientists. So please take the note of that. Scientists use the SI system worldwide. Why? Because measurements are easily understood by all scientists. That's why they use the SI system worldwide rather. Another reason why scientists use the SI system, because measurements are easier to convert than the English system. So for comfort, for convenience also the reason. So there are basic types of measurement that we need to know in this video discussion. The first one, for the length, we have the length. It measures the distance between objects. So we're familiar with the length. Next is volume. Volume measures the amount of space something takes up. Next, the mass. The mass measures the amount of matter in an object. So these are the basic types of measurement. Again, namely length, volume, and mass. So there are also other types of measurements. We include the time, temperature, density, and pH. So now, measurement system comparisons. So let's try to compare the system or the measurement system. Let's start with the measurement in English and SI system. Example, for the measurement of length. For English, we use yard or inch. In SI system, as you can see, I'll highlight, we use meter or centimeter. So see the difference? So for mass, we use ounce or pound for English. And for the SI system, we use gram or kilogram. For the volume, we use quart for English, and we use liter for SI. For temperature, we use Fahrenheit for the English, and also for the SI system, we use Celsius or Kelvin. And for the time, we use second for the English, and same also in the SI unit, second. We use second. So please take note of these so that you'll be able to compare the difference between the measurements of English and SI system. Okay, so let's proceed to the next slide. All measurement systems have standards. Take down note of that. Standards are exact quantities that everyone agrees to use as a basis of comparison. So that's how we define standards in measurements. So now, in the English system, you have to remember so many numbers. Like example, 12 inches in a foot, 3 feet in a yard, 5,280 feet in a mile, 16 ounces in a pound, 4 quarts to a gallon. So in the SI system, you only have to remember one number. That's the difference between the two. The SI system is based on the number 10. The example, the SI system uses the following prefixes. For kilo, we have 1,000. For hecto, we have 100. For deca, we have 10. For unit, of course, we have 1. For deci, 1 over 10. Centi is 1 over 100. And milli is 1 over 1,000. So this system works with any SI measurement. Imagine that. The unit becomes whichever type of measurement you are making. The mass, volume, or length. So it is the system regardless if you are measuring the length, mass, or volume. So please take down note of that. So now it works, the metric system or the SI system of measurement, it works for all types of measurement. If you're measuring mass, then it is the gram or centigram, milligram, or etc. And for the length, then it is the meter, or you use meter, kilometer, decameter, or etc. For volume, you can use the liter, deciliter, hectoliter, and etc. So the first part of the term indicates the amount. The second part indicates the type of measurement. Okay, centi. Example, centi and gram. Again, the centi there, that is the first part. The term centi indicates the amount. The second part indicates the type of measurement, the gram. So we have it centigram. Centi again indicates the amount, and then gram indicates the type of measurement. So I hope you'll be able to know how to use the SI system. How does converting units work? We've done a conversion in the other or in the previous video discussions. This is just a continuation of what we had in conversion in the first part. So unlike the English system, converting in the SI system is very easy. Yes, indeed. For example, in the English system, if you wanted to know how many inches in 2 miles, what would you do when you convert English to metric system? Take the number of miles, 2, which is 2, then multiply it by the number of feet in a mile, which is 5,280. Then multiply that by the number of inches in a foot, which is 12. Then it arrives or it gives you an answer of 126,720 inches in 2 miles. So it's a long process, right? Converting English to metric or metric to English. So here is why scientists use the SI system, because it is much easier. For example, in the metric system, if you wanted to know how many centimeters were in 3 meters, what would you do? Of course, you have here you can just have it, 3 meters is equal to, first find the unit you have meters. So we have 3, right? And then find the unit you are changing to centimeters. So from the meters you have, then try to look where is the centimeters. It is going to the right side of this. So going to the right side, the centimeter, as you can see. Next, count the number of units in between 2. Then move the decimal point that many spaces in the same direction you counted right. So we have 300 centimeters. Why again? So we all know that meter, that is a basic measure, a basic unit or the base unit of measurement. We have the meters, 3 meters going to centimeters. So from the meter going to centimeter, we have 2 units going to the right. So move 2 units going to the right. So we have 1, 2, then add 0. That's why we have it 300 centimeters. Very easy, right? That's how you do the SI unit of conversion, metric to metric. So now more conversions. Let's say 2,321.0 millimeters to meters. So that is equivalent to 2.321 meters, following the step that I discussed a while ago. For 521.0 grams to hectograms, that gives you 5.21 hectograms. And for 8.5 kiloliters to centiliters, that gives you 8,500,000 centiliters. And of course, take note, the digits aren't changing. The position of the decimal is the one that is changing. In the English system, the whole number changes. So do not forget the difference between the two. Things to remember, all measurements need a unit and a number. And basic units of measurements consist of meter, liter, and gram. That these are the basic units of measurements. How to convert metric units, vocabulary words that we mentioned. Now let's proceed to the basic types of measurement. I mentioned we have the length, measures the distance between objects. I also mentioned the volume, measures the amount of space something takes up. And the mass measures the amount of matter in an object. So we also have SI, or in SI, the basic units are, for length is the meter, for mass is the gram, for the volume is the liter, for liquid, and of course, for temperature is Celsius. Take the note. So metric measurement for length. Length is the distance between 2 points. So does not matter if it's width, height, depth, etc. All are length measurements. So that is the length. The basic unit of length in the SI system is the meter. Take down note of that. The meter is about the length of the English yard, which is 3 feet. So area is a variation of a length measurement. Area is length times width, expressed in units square or square units, square meters, square centimeters, square millimeters, or etc. As you can see there on the screen. And now for the mass, metric measurement. A mass is a measurement of the amount of matter in an object. Basic unit of mass is the gram. There are 454 grams in 1 pound. Weight and mass are related, but not the same. Because weight is the pull of gravity on an object. There is gravity acting on a weight. But in mass, there's no gravity. So the greater the mass, the larger the pull of gravity. Take down note of that. And for the volume, volume is a measurement of the amount of space something takes up. The basic unit used for volume is the liter. This unit is used for the volumes of liquids. Volumes of solids are figured using this formula. Length times width times height. That is equivalent volumes for solid. So we have it cubic centimeters. So 1 cubic centimeters is equivalent to 1 liter. Do not forget that one. Objects without a definite length, width, or height, a rock, for example, can use water displacement to determine a volume. This is what I said. 1 ml is equivalent to 1 cubic centimeter. Sorry, just mistaken a while ago. 1 ml is equivalent to 1 cubic centimeters. So for temperature, we have it here. Temperature is a measure of the kinetic energy of the atoms in an object. That is the movement of kinetic energy in an object. That is a temperature. Temperature is measured with a thermometer and measured in Celsius or Kelvin. Celsius ranges from 0 degree, which is a freezing point, to 100 degree, which is the boiling point. The Kelvin scale begins at absolute zero or 0 Kelvin. At 0 Kelvin, no more heat can be removed from an object. So to convert to Kelvin, you add 273 degrees to the Celsius reading. So in freezing, in Kelvin is 273 K or Kelvin or degrees Kelvin. Boiling is 373 K in Kelvin. So do not forget, freezing is 273 in Kelvin. Boiling is 373 in Kelvin. Okay, so now which is heavier? A kilogram of feathers or a kilogram of lead? I want you to think about that. Which one takes up more space or volume? Now let's see, there are both 1 kilogram, so they weigh the same. They weigh the same rather, but it takes more feathers than lead to equal 1 kilogram, correct? So take note of that. So we say the lead rather is more dense than the feathers. And density is how much matter is in something or mass compared to the amount of space it takes up in volume. So the formula for density is mass is divided by volume or cubic centimeters. So the unit for density is G over centimeter cube. So every substance has a density, and that density always remains the same. Take note of that. Density can be used to figure out what an unknown substance is. So the density of water is equivalent to 1 gram per cubic centimeters. A centimeter rather. So measurement review. Let's try to review two before we end our video discussion. Measurements need a number and a unit. Basic units of measurements are meter, liter, and gram. How to convert metric units? We mentioned it a while ago. English to metric, metric to English, and metric to metric. Be able to make basic measurements of volume, length, and mass. And of course, definition of density and how to figure it out. Vocabulary words. We mentioned several vocabularies or terms related to measurement. So I hope you learned something in this video discussion. Always remember, the essence of mathematics is not to make simple things complicated, but to make complicated things simple. Math is fun. Thank you for listening. Have a good day, everyone.